Hi, today we're going to be talking about graphing a linear inequality. Okay. The idea is you want to graph on an XY coordinate grid the solutions to that inequality. So let's say I want you to graph y equals 1/2 x minus 3. Okay. Just so we're clear, this is not an inequality. This would be an equality because of the equals. But if we were to plot this, we would start with our y-intercept, and then our slope is 1/2, so I can use that as a rise over run, rise by 1, run by 2, to continue to find other points on my line. I don't know if you've ever thought about it like this before, but when you are graphing a line, what you're doing are identifying the solutions to this equation. Okay, you're identifying visually what are the x and y coordinates that would make this equation true. So I plotted 1, 2, 3, 4, 5, 6, 0. So I might ask you, is 6, 0 a solution to this equation? And we could plug it in. Half of 6 is 3, and then 3 minus 3 is 0. Yeah, it is. What if I asked you like 2, 3, so like a point up here? Is that a solution to this equation? Okay, we could plug it in and we would probably find that no, that ordered pair would not make that equation true. So we don't plot that point as part of our line. Okay, your line is literally a visual representation of your solutions. So what if I were to change it to y is less than or equal to 1/2 x minus 3? What we're going to do is visually represent where are the xy coordinates that would make that inequality true. Okay. We will plot a solid line whenever it's less than or equal to, because we want to represent that those are solutions as well to our inequality. Now, because it's an inequality, we're going to have more ordered pairs than just the ordered pairs that are on the line. What we could do is check an ordered pair that's not on the line. So maybe I want to check 0, 0. So I want to check the ordered pair 0, 0. And I'm going to plug it into the inequality. So I'm wondering, is 0 less than or equal to 1/2 times 0 minus 3? That would say 0 is less than or equal to -3. And that is not true. So I know that 0, 0 is not a solution to my graph. Okay. I could test another point, maybe like 5, 5, so like a point up here. But I could tell already that that would not be a solution as well. And the reason why is if 0, 0 didn't work, then no points on this side of my equation will also work. So let's try a point that is below our line. Maybe like, I don't know, negative or 5, -5. So I'm going to check 1, 2, 5. This random point, 5, -5. I'm going to plug it into my equation. So I'm wondering, is -5 less than or equal to 1/2 of 5 minus 3? -5 less than or equal to 5/2 minus 6/2. So because I'm going to be subtracting, I wanted to make them common denominators. -5 less than or equal to -1/2. That is a true statement. -5 is less than -1/2. So 5 is a solution. And we could be testing other points, but we would find that all the points on this side of our line would also be solutions. So we want to represent that those are solutions by shading that side of our plane. Okay, so we have a solid line to represent that we have solutions that are on the line, and the shading is also identifying that any point on this side of our line will also be a solution. Okay. Let's try another one. let's try x plus y is less than 3. What we want to do is start with plotting the boundary line. And so that's essentially the line x plus y equals 3. So if you're considering this inequality as an equality, that's identifying the boundary. Because it's just a less than and not less than or equal to, the way that we show that is with a dashed or a dotted line. So graphing x plus y equals 3, standard form we plot the intercepts. So our y-intercept is 3, and then our x-intercept is 3. Oh, I forgot what I was saying, wasn't I? Those should be dashed. Ignore that up there. That should be dashed. Okay, so by dashing our line, we're showing that this is the boundary line, but that we're not including the points that are exactly on that line as solutions. So if we tried like 3, 0, is 3 plus 0 less than 3? No, it's actually equal to 3. So if it's strictly less than, then we want to use a dotted line. Okay, from here we want to test a point. My typical go-to point that I check with is 0, 0, and that's because it's the easiest point to plug in. So let's try 0 plus 0. Is that less than 3? Yes, in this case. So I know 0, 0 was a solution to this inequality. All the points on this side of my line are also solutions. So I'm going to shade in that entire side. Okay. Now we've noticed with these two examples, y less than or equal to negative or 1/2 x minus 3, that we shaded down. So when I talk about down, I'm like, if you were to pick a point on the graph and you shade down. Okay. This one, x plus y less than 3, less than, we shaded down. So my question to you is, does that always work? What do you think? Take a guess right now. Okay, so the answer is not always. Let me give you an example. If you had x minus 2y greater than or equal to 4. Okay. Based on what we saw, greater than should be graphing up, but let's see what happens. It's in standard form, so we're going to graph the boundary line using the x-intercepts. So our x-intercept would be 4, and then the y-intercept, if you divide both sides by -2, your y-intercept is -2. Because it's equal to, I'm going to use a solid line. And once again, I want to check an ordered pair, or test an ordered pair in my inequality to see if I'm going to shade up or shade down for my line. I'm going to check with 0, 0. So 0 minus 2 times 0 is greater than or equal to 4. Is that a true statement? Is 0 greater than 4? No. So I know negative or 0, 0 was not a solution. That means no points on the upper side are solutions. In fact, all of our solutions are falling on the bottom side. So here are our solutions for this one. So the question, greater than, do we always shade up, and less than, do we always shade down? Not necessarily. That's really only true if it's in the form of y equals mx plus b. In that case, you can say less than or equal to, you shade down, and greater than or equal to, you shade up. But you have to be careful, especially if it's in standard form, that may not be the case of shading up or down. So it's really important that you're actually testing an ordered pair. So our steps for graphing an inequality. The first step is to graph the boundary line. And so that would be the inequality just written as an equation, but you want it dashed or dotted, depending on if we're including points or not. From here, we want to test a point that's not on the line. Typically, I like to use 0, 0, but it doesn't have to be. All you're doing is testing to verify what side of the plane you're graphing. Okay. Lastly, if it's true, you shade that side. If it's false, you shade the other side. Okay, so that is how you'll graph linear inequalities. Thank you.